So I did my research in distributed graph processing, particularly in graph partitioning. So if you look at my Google Scholar profile, you will see there are a lot of like graph partitioning algorithms here. And in today's today's video, I want to check if Koala, so the Koala writer that that we often discussed on the Thinkset channel, is actually able to write, say, semi-scientific articles on those type of scientific topics. And why do I like? I thought that there should be like this idea of using Koala writer in a way that was not used by other people before. And yeah, in this video we are going to test this out. So first of all, so what I did is I used Claude 3.5 Sonnet, the best model, and blog post, and as target keyword I used the graph partitioning, a graph partitioning question. Like I started with an overview question. I don't want to focus too much on SEO because this should be more like a research-based article, right? And I think there could be a way or an angle how we can AI generate a useful research site, or a site like that is tailored or addressed towards researchers, and maybe giving them some background information. And what I do, like, I don't embed any YouTube videos or AI images because it's more scientific. As article length, we use default. And now tone of voice, we should be more like we use custom and put in scientific, right? So this is our like the tone of voice should be scientific. As point of view, we use the first person plural, so we, us, ours. So because this is just a standard in scientific writing, and we use real-time data. And this is like the most important step here. Use real-time data, and we use Scholarly here. So we click on Scholarly. What does it mean, Scholarly? So if you click on documentation, you will see Scholarly means that we only use sources available from Google Scholar, right? So it just searches Google Scholar and gives the sources that are provided there. And this way we can avoid like low quality web content, or just using other articles as sources, and we can focus on scientific sources. And this way I think we can write a useful article. Okay, so let's try it out. If you click create article, we will actually get this article. And yeah, here the article, what are 3 best graph partitioning algorithms, a comparative analysis of computational efficiency and scalability. So the title already like is, I would say, like sounds scientific, right? But yeah, let's see what the article gives. There are no images, right? We didn't generate any images. And first what I tried is I just copied this whole text, I put it into ChatGPT, and in ChatGPT here above I asked it to rewrite the article with LaTeX formatting applied. So the idea is, and I simply pasted the article here. The idea is that if you can paste it here, we will get actually something like this, right? So we can use a paper like graph partitioning algorithms, spectral, multi-level, and geometric graph cuts. This was actually an article generated by the Claude 3.5 Sonnet Anthropic model using Koala writer. And it like ChatGPT automatically rewrote the article and applied the kind of LaTeX style formatting you see right here with this state machine approach, like begin abstract and then you write the abstract. So it already looks great, right, with the bullet points and everything. So it's a like the formatting is already pretty nice, and we could write papers like this. But now, like just as an example, I give also a link in the description below so you can browse this article. I have published it as a sample article on the Thinkset blog. What are the 3 best graph partitioning algorithms, a comparative analysis, and yeah, the overview. Let's quickly go over the article. First, it gives an overview. What is graph partitioning? Graph partitioning divides a graph into smaller components. And yeah, maybe before I dive here into the more technicals, if you want to check out this tool as well, then also look in the description. I will give a link to the Koala AI writer and also a discount code Thinkster that if you apply this discount code, you will get 15% off forever of this tool. And as I said, there are some angles here how we can use this to create a scientific website, or a more scientific like a website of scientific topics, right? Maybe linking to scientific articles and stuff. And we could apply this to computer science or computer science concepts, or we could apply this to like different niches, right? And say health or wealth or relationship or anything in between, right? Biology, whatever we want, we can focus on a specific sub niche and then generate like useful, more scientific articles in this niche. And hopefully these articles will really provide some value because they compile important scientific papers into a single article, or like a mini paper that kind of distills the most important information from those works. Okay, so let's dive into the quality of this article. The definition, first it defines graph partitioning. What is the idea of graph partitioning? We want to reduce the computational complexity. We want to enhance parallelizability. So we can partition the graph in a parallelized way. So with multiple CPUs or even GPU, highly parallelizable. We want to improve data distribution and facilitate load balancing in networks. Okay, so this is more like applications or general goals. Here are some specific applications. We use graph partitioning in scientific computing, database management. For instance, if you have the social network, the Facebook social network, we want to distribute the social graph of Facebook is network. If you want to compute this network, we actually want to distribute the data among multiple workers, so we can do some distributed graph processing or partitioning. And we also use it in chip design, right? For instance, NVIDIA, I've read another paper from NVIDIA. They use graph partitioning for their VLSI, so the chip design. And of course, GPUs are also useful. And if you want to do graph partitioning in GPUs, then we should focus on parallelizability. Okay, and the AI writer actually has given us, say, more like a very rough introduction into this topic, very broad introduction. There are not too many specific useful informations, but I think it's a good like first article or first read to get an overview of the field. But let's specifically check out the partitioning algorithms it proposes, and I will honestly say give you my estimation on whether those proposed algorithms are actually helpful. So as partitioning criteria, we use balance. So the partitions should have approximately the same number of nodes. We want to minimize the cut size, so the number of edges crossing from one partition to the other partition, because this induces communication overhead and computation overhead. And we want to maximize connectivity on the subgraphs on each partition. And actually, what it proposed here right out of the box is the Kernighan-Ling algorithm, and this is actually one of the most popular graph partitioning algorithms. It's already pretty old, so let's check out from when this algorithm is. So it's like from 1997, right? So a pretty old algorithm, but it's a great algorithm. It's a great paper, really recommended read for every computer scientist. So definitely check out the most important papers, and you see the links directly linked to the scientific sources. So it's really useful, useful writer. Then it also gives us like spectral partitioning algorithms. So this was like more about multi-level, right? Multi-level, now probably we'll go into multi-level. Spectral partitioning algorithms, let's check out the sources if they actually fit. So this is a more math-based approach where we try to project the multi-dimensional graph, if you want, to a two-dimensional plane, and then based on this we can do some partitioning. So it's a very rough way of explaining it, but I hope this does it. Okay, so it gives us a reference, an improved spectral graph partitioning algorithm for mapping parallel computations. And you see, like, the better the Google Scholar actually finds us, the better Google Scholar proposes to us, the better these AI written articles will get over time, right? And I suspect that they will soon get better than, say, a grad student or so writing those type of articles. And okay, so it explains spectral partitioning based on eigenvalues and eigenvectors and so on. It even gives us some math, like defining the Laplacian matrix L and Fiedler vectors and stuff. And yeah, so it also gives us this multi-way partitioning, which is also very popular graph partitioning algorithm, and gives us the way of recursively applying this. Where did it get this from? Here, from this paper, from this 1994 paper. So it's like not the most recent information, right? But probably if we had like a 2024 bracket, if we would basically add 2024 here in our keyword, here somewhere. So the target keyword here, we would use like graph partitioning algorithms overview. Something like this would be our keyword, and then we could also put in 2024, for instance, to get maybe more recent papers. I think this should work as well. Okay, so it then gives us the multi-level partitioning, which is also very, very famous. Multi-level recursion, bisection. Let's not go into this. Nobody actually is interested in graph partitioning. I have learned the hard way, right? After 4 years of doing a PhD in this field, I now know that nobody actually cares about graph partitioning algorithms. It is what it is, right? Okay, but one thing I wanted to show you, like here, it gives us even links to commercial tools, and the commercial tools, for instance, and open source implementations of those commercial tools are like the Metis library. And Metis, like if you work in the field, everybody in the field, in the graph processing field or graph partitioning field knows the Metis library. It gives us a link to the library, which is kind of a standard benchmark, right, that we all compare our partitioning algorithms against. Good, so I think it's an excellent article. So if a student would have written this article, I would give it probably a good grade, and it has some background information. It is well researched. It doesn't go into depth, but this was also like not what I was asking it for. So yeah, I think it did a great job. This way, like I feel like here's a great business idea for you, maybe if you want to like do something in the field, something like help advance research in a way, right? You could write simple or fill simple research gaps with this AI writer. Then it would be more like about the research, like finding the research gap, right? In blogging, we would say keyword research, or finding some content gaps in the research, in the broad research field. And this way we can maybe in a day or so fill it with good content using this AI writer. And I found it the content quality is generally better, at least for a general public, than just using ChatGPT, because just using ChatGPT would not use the Google Scholar search result page. Okay, so just want to share this with you. If you want to check out the Koala writer yourself, write your own articles that you can then publish online, get some traffic, maybe monetize the traffic, then check out the link in the description below and use the discount code Pfingster to get 15% off. Give me a like and subscribe to this video if you like to stay on the right side of change amidst rapid disruption in our field, and see you in the next video. Bye.